Hello students, this video is for the Chapter 1 multiple choice review. We're going to be talking about all of the multiple choice questions that I gave you for Chapter 1. There are a lot of questions. I'm going to try to go through them as quickly as possible. They deal with histograms, they deal with two-way tables, IQR fences, tests for outliers, the whole 9 yards. Let's take a look. In this first question, it gives you a two-way table for female and male respondents for this survey. It asks for number one, the percent of females among the respondents. So in other words, the percent of females out of the total. The females, adding them all together in these individual cells, is 2,625. The males is 2,252. In order to get the percent of females among the total respondents, 2625, the females divided by the total, which is all the males plus all the females, is equal to 0.53824, etc. This is a relative frequency. You can think about it like this. It's also a decimal. We can convert this decimal into a percentage, 54%. Not too bad. For number two, you percent for the previous exercise is part of, and this is an example of what I was talking about during class, how some of the questions sort of look like all the answers are the same. The correct answer here is marginal, because we're not talking about females that have a 50-50 chance or males that have almost no chance. We're talking about all of the females, all of the people in this particular category. So the marginal distribution of gender, females versus males. Keep in mind, if it's broken down into specific conditions, then we'll be talking about conditional distributions. If it's not broken down into specific conditions, we're talking about marginal. It's not a marginal distribution of females, because then we would differentiate between females that have almost no chance, females that have a 50-50 chance. The data is given to us in marginal distribution of gender, male versus female. We gave 54% for female, and of course about 46% for male. For number three, what percent of females thought they were almost certain to be married in the next 10 years? It's asking percent of females. So I'm not dividing by this large number, which is 4,000, about 900. We're going to be dividing by the total number of females. So percent of females thought they were almost certain to be married. These females were almost certain. Remember, we're only looking at the female column, 1,174. We're dividing that number by the total number of females, right? And we're getting 0.447. That's about 45%. Now for this next question, your percent from the previous exercise, we've taken females and we've broken them down. We've broken that specific category of females, and we've broken it down into certain conditions, almost no chance, some chance, etc. So if we've broken down into conditions, we're no longer talking about marginal distribution. We're now talking about a conditional distribution. So if you recall in question 3, it asked what percent of females. So we're talking about a conditional distribution of gender. We're not talking about of opinion. So, and we know that it's going to be conditional, so it's got to be conditional. It could be C, D, or E. But it's not talking about the conditional distribution of the phrase almost certain. It's not talking about the conditional distribution of opinion. We're asking percent of females. So we're looking for a conditional distribution of gender. Among adolescents with a given opinion, the opinion we're talking about, of course, is almost certain in this case. So 45% of females, conditional distribution of gender, were almost certain to be married among adolescents with a given opinion. Not too shabby. For question 5, what percent of those who thought they were almost certain to be married were female? So percent of those who thought they were almost certain to be married. Now my total is all of the people who thought they were almost certain to be married were female. Female is now my numerator, the females in that particular opinion. So going back to the chart, we're looking at the almost certain to be married row. Almost certain to be married is this row right here. So among all of these people, how many of them were female? We have 1174 divided by the total of 1174 plus 756. And that value should be just about 0.608, about 61%. So those 5 questions are about the two-way table. In this next question, here are the amounts of money carried by 10 students in a stats class. I don't know who carries around coins nowadays, but here are those values. If we were making a stem plot of the data, you would use stems. It's asking for which part of these data you would use for stems. And it's clear that all of these data, even the zeros, have a value for tens, right? This has a tens value of 5. This has a tens value of 3. This has a tens value of 9. The zeros have a tens value of 0. So we've already established that the stems are going to be the first number. It's not going to be 2 numbers. We're not going to combine 2 numbers with a leaf, because remember, in order to make a stem and leaf plot, this would have the stem of 5 and the leaf of 0. So we're looking for single digits here. Also, when you're doing a stem and leaf plot, you can't create a stem and leaf plot and jump numbers. You can't go from 0 to 2 to 3 to 5. It has to be all of the stems in order, regardless of whether you have data for those stems or not. So 0, 3, 5, 6, that's not going to work for me. 0, 2, 3, 5, that's not going to work for me. A stem plot has to have consistent jumps between the stems, and you can't skip any. So your correct answer is choice A, 0, 1, 2, 3, 4, 5, etc. Remember, if a stem plot doesn't have any leaves for a particular stem, that's okay. You have to make sure that you're not skipping anything. That's like if you were graphing a point on a coordinate grid, and all of a sudden you went from 0, 1, 2 to 4, you can't do that. For number 7, it talks about house prices from 200,000 to 500,000. There are some prices that are up to 15 million. Those are the big mansions. The distribution will be, well, you have a lot of data down at the low end of the scale, but at the high end of the scale, you're going to have like 1 or 2 that's super, super expensive. Looks to me that there's a big tail to the right. If there's a tail to the right, we talk about skew to the right. And sometimes it's helpful to draw out that distribution. If you wanted to do that, make sure that your distribution is labeled correctly, right? We're talking about, 100,000, 200,000, 300,000, etc. That 15 million, that's actually going to be much higher. That's going to be up here somewhere. Anyway, moving on to questions 8 through 10, which refer to this histogram. It says the leftmost bar in the histogram, that's this bad boy right here, covers percents of never married women ranging from about, well, let's see, it starts at 20. And we're talking about percentages of women. So if it starts at 20, we can eliminate choice C and choice D. It ends at this point here, and I'm not sure what that point is, but I know that from here to here, that's a jump of 4%. From here to here, that's a jump of 4%. So halfway is going to be a jump of 2%, from 20 to 22%. The center of the distribution, well, looking at this distribution, looks like it's skewed to the right, but the center of the distribution isn't going to be too far away from that peak that you see there. It looks like there's only about one state here that has that odd percentage, so we're going to take a look at the center being right around here. Looks like that center is between 24 and 26. Look at us, 24 to 26. Another good rule of thumb, look for where the majority of the data is, and look for that peak. Moving on to question number 10. In question number 10, it asks what percent of states have at least 30% of women aged 15 or over never married. We can look at the histogram to figure that out. This next question asked about what percent of states have at least 30% of women, so 30% or above, age 15 or over, never married. So here's the 30% marker. It's between 28 and 32. So we're counting all of the states that are at least 30% of women. So this bar, and this bar. And we're dividing that by the total number of states, but keep in mind we're doing each of the 50 states and the District of Columbia, so we're dividing by 51. You can count the levels of these bars very easily, 5, 1, and 1. So we know that 7 divided by 51 is equal to 0.137, etc. That sounds to me like we're talking about 14%. The next question, if a distribution is skewed to the right with no outliers, well, I don't know, let's draw a picture. Skewed to the right with no outliers. So that means we got a lump of data to the left-hand side, and then it sort of tails off to the right-hand side. Keep in mind, it's got no outliers, but it does have this tail to the right. A tail to the right means there's data values here somewhere, which means it's going to pull the mean this way. However, the median, which is resistant, stays right around the clump. So we can call this the median, and we could call this maybe the mean. And I'm making a little curly mu. Okay, so that mean is a little bit higher than the median. Well, let's see. The mean is less than the median. That wouldn't make sense. The mean is equal to the median. That wouldn't necessarily make sense. Mean is about equal to the median. Like we said, it's got a skew. Mean is greater than the median. That sounds about right. So number 11 is choice D. Number 12, you have data on the weights of 5 baby pythons. Ew. The mean weight is 31.8 and the standard deviation is 2.39. The correct units for standard deviation, well, keep in mind, we talked about units for standard deviation. That's the exact same units as the units for the data set in general. So the weight in grams is for the mean, so 31.8 grams. And the standard deviation is also measured in grams. Keep in mind that the standard deviation is always going to be the same unit of measurement. Pythons would make sense. imagine the standard deviation being 2.39 pythons. Well, that's crazy. Which of the following is least affected if an extreme high outlier is added to your data? Remember, if it's least affected, that means it is most resistant. We can get rid of a couple right away. The maximum, if an extreme high outlier is added to your data, that's going to be the new maximum. Range is also highly affected by extreme high outliers or low outliers. The standard deviation and the mean are both similarly affected by high outliers because the mean and the standard deviation are calculated, well, let's see, the standard deviation is calculated based on the mean, right? The one that we talk about as a resistant measure of center is the median. That would be choice A. Moving on to question 14, all the values that a standard deviation could possibly take. Well, remember that a standard deviation is going to be anywhere between 0 and, well, I guess there's no upper limit, right? The standard deviation is the average distance away from the mean. So the standard deviation just has to be greater than 0. But wait, you might say, the entire distribution could have the same exact value. I guess that's true. So instead of saying that it would be greater than 0, I have to say, well, it could be 0 or it could be any other number that's bigger than 0. So it seems to me that question 14 is choice A. It's anything greater than or equal to 0. That was in the notes. You record the age, marital status, and earned income of 1,463 women. You've recorded number and type of variables, or I should say you've recorded some variables. How many of them and what type are they? Well, age, marital status, earned income. Seems to me that that's 3 different variables. If I'm talking about 3 variables, 4 is right out. 3 and 1, that's no good. 2 and 2, that's no good. I got 2 and 1, I got 3 and 0. Okay. I know that age and earned income are both numerical. We can compare them. Like one person might be older than the other. One person might earn more. But marital status is either single, married, divorced, widowed, etc. So I would say that that is 2 quantitative, 2 with data that can be compared, and 1 categorical, one that can't necessarily be compared, added, subtracted, that kind of thing. Moving on to the next page, we're talking about gas mileage in miles per gallon of 38 different vehicles. That information should be in the pie chart, but it's not here. Let me paste it in right now. All right, here's the pie chart, and I think we can all agree it looks pretty disgusting. 38 vehicles from the same model year on a special test track. Keep in mind, this pie chart is just talking about or showing us the country of manufacture of the cars. Where it was made. So we don't know anything about how much lower gas mileage there was. We don't know about higher gas mileage. We don't know whether the gas mileages are between those of Japanese and U.S. cars. It's not telling us this information. It's just telling us this many cars came from the U.S. This many cars came from Germany. Nothing here is talking about gas mileage. Mercedes, Audi, Porsche, BMW. These are car manufacturers not even talked about on the chart. The chart is only showing that all of these cars from here all the way around to here come from the U.S. So more than half the cars in the study were from the United States. Should make sense to you. Earthquake intensities are measured using a device called a seismograph. It's actually pretty cool to watch the seismograph work. And now this question is asking us what the median earthquake intensity is. All we need to do is try to determine which value is in the middle of the values when we list them in order. So let's do that. Of course, we have to keep in mind that this L indicates that it was below 4, and both of the H's represent numbers above 9. So let's list them out in order. And I know what you might be thinking to yourself. Well, this is a little unconventional because this is a list, but it's not all numbers. That's okay, because when I'm trying to find the median, I don't need numbers necessarily. I just need them all in order to be able to figure out which value is in the middle. So 1, 2, 3, 4, 5 away from either side. 1, 2, 3, 4, 5. The median is going to be 6.0. It's okay that it says 6.00 because an extra 0 never hurt anybody. Moving on to questions 18 and 19, we're still worried as statistics professors about how much money people have in their pockets for some strange reason. It asks for the percentage of students with less than $10 in their possession. Easy to figure that out. The amount of money, here's $10. Oh man, the importance of clear and easy labeling. Here's $10. We need to figure out how many students have less than that. So we look at the bar and calculate the frequency in there, and then calculate the total number of students. And the writers are a little coy. We're looking for closest to. The answer is 44.1%. 44.1 is closest to 50. It's closer to 50 than it is to 35. For question 19, it asks which is not correct. So let's look at the correct ones. The histogram is definitely right skewed. The median is definitely less than 20 because the peak is right here, less than 20. The IQR is 35. That's a little suspect. The mean is greater than the median. We know the mean is greater than the median because it's right skewed. In a right skew, the mean is greater than the median. The histogram is unimodal. That's right. There's only one peak. So the IQR being 100 or 35 is the correct wrong statement. For question 20, we have all of these data values and we're looking for the third quartile, so we sort of need to find where the third quartile would lie. And in a list of 40 values, there's 10 values in between each of these. So I'm looking for the value that's in between the 10th and the 11th from the top. So 3, 4, 5, 6, 7, 8, 9, 10. Looks like it's going to be between 44 and 44. Answer is 44. All right, moving on to question 21. The mean salary is $35,000 for female workers. The mean salary of male workers is $41,000. What must be true about the mean salary of all workers? Okay, well, you don't know how many female workers there are and how many male workers there are, but you know that they're all part of the same workforce. And you know that the mean of one group is $35,000, the mean of the other group is $41,000, but we're going to mix those two groups together in order to make the entire workforce, all workers. So that number has to be somewhere in between $35,000 and $41,000. So we don't know exactly where it's going to be, but we know it's going to be in between those two numbers. Do we know anything about the median based on this information? No. So I don't know why we're talking about median here. Do we know whether it has to be larger or smaller than a certain number? No. We don't know anything about that because in order to know that, we need to know how many female and how many male workers there are. All we know is could it be any number between 35 and 41. It's a little frustrating to be a little vague like this, but there we go. For questions 22 and 23, we're referring to this two-way table with small, medium, and large. First question, what percent of all small companies receiving questionnaires responded? We're looking for the percent of all small companies. Of means divide by. All small companies, that's going to be your denominator. And of course, we're looking for the ones that did respond. So we're looking for the responses for small only, which is 125, divided by the total for small only. Remember, we're only talking about all small companies, not all companies in total. So we got 62.5, which should be this choice, which is choice E. Last but not least, we're looking for a conclusion that seems to be supported by the data. So let's go through them one at a time and try to figure out whether they make sense. Let's see if they pass the sniff test. The first one, there are more small companies than large companies in the survey. Looks like there are the exact same number of large and small companies in the survey, so that's probably not true. Small companies appear to have a higher response rate than medium or big companies. Higher response rate, well, in order to figure that out, we could find the response rates for all of these. 125 divided by 200, that's 62.5, we already got it. 81 divided by 200, I don't know it off the top of my head, but it's got to be lower because it's the same denominator and it's a smaller numerator. So this one's definitely smaller, this one's definitely smaller. Small companies appear to have a higher response rate. Okay, that looks pretty good so far. Exactly the same number of companies responded as didn't respond. These numbers don't match up, folks, right? So it's not the same number that responded or didn't respond. Small companies dislike larger companies. Couldn't possibly tell you from the data, not borne up by the facts. If we combine medium and large companies, then their response rate would be equal to that of the small companies. Well, let's test that out. And when you combine the medium and large responders, that's 121. That's essentially the same as 125, right? But remember, we're talking about a response rate. The rate is going to be divided by the total. So, of course, we're talking about 121 divided by 400. What's that going to be? About 31%, 30.25%. That's nowhere near the percentages that we found of 62.5. So that, again, does not pass the sniff test. Looks like the one that we thought was right at the beginning is definitely the one that's right at the end. Choice B. All right, folks, that was the review for the Chapter 1 multiple choice. Good luck studying.